The next flip-flop which we are going to look into is JK. JK flip-flop is constructed in order to overcome the difficulty which we are facing in SR flip-flop. What was the difficulty we had? We had two indeterminate states. Whenever Q is 0, S is 1, R is 1, we are getting indeterminate. Similarly, when the Q is 1, S is 1 and J is 1, we are going to get indeterminate state. So in that particular situation, we are going to construct a JK flip-flop by using two AND gates and two NOR gates. And how is this construction different from your SR flip-flop? SR flip-flop just had only T here. That means clock pulse, SR and the outputs Q and Q dash. But here what is happening? The output is again given as an input for the, so there are three inputs which are coming for the AND gates. Three inputs coming for the AND gates. And the graphical symbol for this will be J is the input, K is the input. This is the clock pulse which is coming and Q dash. Now just see the characteristic table. This is the present state, next state J and K. So whenever your present state is 0, 0, 0, 0. Now what is the output I am going to get? Q is 0. Okay, when this is 0, the first one is 0. The clock pulse is coming 1. The clock pulse here is 1. When Q is 0, Q dash must be 1. So this is going to be 1. Now what is my present state of 0 and 0? 0, 0. 0 into anything is 0 for an AND gate. 0 into anything is 0 for an AND gate. Now here this is 0. 0 plus 0 complement is 1. 1 plus 0 complement is 0. Hence I get 0. Let us see another case. 1, 0. This case I am going to take up. Your present state is 1. What will be my J and K with 0, 0? Present state is 1. That is Q is 1. So Q is 1. So this is going to be 1. What is my J and K? Both are zeros. 0 into anything is 0. 0 into anything is 0. Now let us see, this is 1 because I have given my Q as 1. 1 plus 0 complement is 0. Here the 0 comes. 0 plus 0 complement is 1. Hence we are going to get 1. Like this, each case we are going to get different answer. Now once we get this, the next one is the characteristic table. Characteristic equation we have to get from the table. Now how do we get that? Q, J, K. Where are the points where I am going to get ones? This is 0, 1, 2, 3, 4, 5, 6, 7. Now just see here, 2 is 1, 3 is 1, 4 is 1. So 2, 3, 4 and one more is 6. 6 is 1. So I'll club these two, I'll get J, Q dash, and when I club these two, I get K dash Q. Hence the characteristic equation is being obtained. Apart from this, we also need an excitation table. The excitation table is constructed like this. Present state, next state, 0, 0, 0, 0. But what is the change I have? J is 0 constantly, so I get 0 here. But here K is changing, so I put it as don't care. Next, 0, 1, 0, 1, 0, 1. What is my J? J is 1. What is my K? K is changing from 0 to 1, so it's a don't care. Next, 1, 0, 1, 0, 1, 0. Now just these two. If you see J, it is changing from 0, 1, so it's a don't care. And this is remaining constant as 1, so K is going to be 1. The last one is 1, 1. Now if you just see here 1, 1, present state and next state. Similarly 1, 1. What is my, these two rows if you check? J is 0, 1, so J will be don't care. K is 0, 0, so K is 0. Hence we have constructed and studied a JK flip-flop.